Scientific notation can be really useful when we want to show which zeros from a calculation are significant. Here's what I mean. Let's say that we do this multiplication problem right here. The answer that we're going to get is 7,000. Okay? How many significant figures should our answer have? Well, there are 4 significant figures in both of the numbers that we put together. So our final answer should have 4 significant figures in it. But the way it's written right now, it only has 1 significant figure, the 7. Because, as we've talked about, zeros to the right of a non-zero digit are only significant if there's a decimal place in the number. So one thing that I could do to show that these 3 zeros are significant is to add a decimal place. Okay? That's one thing I can do. But the really, really precise and accurate thing that is like universally understood is to put this number into scientific notation. Okay? So write this 7,000 as 7.000, and I'm going to move the decimal place 1, 2, 3 spots to the left times 10 to the third. Okay? Now there is no doubt at all that these zeros are significant, because zeros to the right of a decimal place are always significant if they follow a non-zero digit. Okay? So now we know that there are 4 significant figures in this number. Here's another example. We do this division and we get 2,000. Okay? There are 4 significant figures here. There are no non-zero digits. And there are 5 significant figures here. We don't worry about the 0 that's at the end because there's no decimal place. That means that our final answer should also have 4 significant figures. Again, I could put a decimal place here, but it would make a lot more sense. It would be a lot cleaner and neater if I wrote this as scientific notation, as 2.000 times 10 to the third. There is no question now at all that all of these digits are significant. Okay? Now, this gets increasingly useful as we start looking at problems like this. Okay, this is harder than it seems. I do this multiplication here, and the answer again that I get is 2,000. Okay, it doesn't seem like a big deal, but let's look at how many significant figures it should have in it. Okay, 3 significant figures here because of the right-hand zeros in the decimal place. 4 significant figures here. Okay, so I want 3 significant figures in my final answer. So I'm going to keep the 2, and I'm going to keep these 2 zeros, but not this 0, right? So I don't want to write it as 2,000 because then it only looks like there's 1 significant figure in it. But if I put a decimal place to the right, that means that all of the zeros are significant. In this case, it's super important to put it in scientific notation, and in fact, that's the only way that I can show that these 2 zeros are significant, but this one is not. Okay? So I'm going to write this as 2.00, moving the decimal place 1, 2, 3 times 10 to the third. Using this notation, I show that there are 2 significant zeros in the number, but that the third one is not significant. 2.00 times 10 to the third. Here's another example. This particularly becomes a big deal when we're rounding. 86 times 23, 1978. Okay? 2 significant figures in both of the numbers that we put together, which means that we want to round this to 2 significant figures. So we keep the 1 and we keep the 9. Okay? But what we do is we look next door to see whether we should keep the 9 the same or round up. Well, it's a 7, we should round the 9 up. But when we do that, that's going to round to 10, so that's going to bump the 1 up to 2. So what I'm going to get is I'm going to get 2,000. Now, how many significant figures should this answer have? It should have 2. I want to keep the 2 and I want to keep the 0, but I don't want to keep these numbers to the right here because they are not significant. So again, scientific notation is the best way to show this. I write this as 2.0, showing that that 0 is significant, and move the decimal place 1, 2, 3 things over. So I'm going to have 2.0 times 10 to the third, showing that there are 2 significant digits in this calculation. This one and this one are significant, but the others are not. One final example, 8.9 times 56 is going to give me 498.4. Again, two significant figures in both of the numbers that I'm multiplying together in the first place, which means that I should round this to two significant figures. I look over there, the 8 means that the 9 should round up, which means that the 5 should go up. So I'm going to get 500. But there should be only two significant figures in my final answer. So I keep the 5 and I keep the 0. This 0 is significant, the 0 to the right is not significant. So I will write this as 5.0, two significant figures, move the decimal place over, 1, 2 times 10 to the second. So that is how I take numbers like this that have a number of zeros, a whole bunch of zeros, and how I show which of those zeros are significant and which aren't. I have to put the number into scientific notation to do that.